Hello, assalamu alaikum, Zabi or India students. Today we are discuss to factorial, that is related topic with the combination and permutation in probability chapter. So first of all, we can define how we can write the factorial terms. What is factorial? Factorial notation. Today lecture is very interesting because we have very interesting topic from the probability. So first of all, what is factorial? How we can define to express all the positive integer which is less than or equal to the number of terms n. So it also can be defined as to express the product of first natural numbers, that is called 1 to up to so on up to terms. So we can write, there are two definitions. One is to express the product means multiplication, the product of first natural numbers, first n natural numbers, or we can say that the product of positive integers, which is less than or equal to n, which is less than or equal to n, which is less than or equal to n. Now how we can represent it by notation? So in that notation is called factorial. Read as in factorial. So means that we can write this term in factorial. We can write 1, 2, dot 3, dot 4, dot 5, dot up to so on, dot up to n times. So this term we can also write, that is called descending order, and descending order we can write in dot up to so on. If we can write this term 5, 4, 3, 2 and to 1, that means that this term is reduced in the form of this one, n minus 1, n minus 2, n minus 3 up to so on. We can write 3, 2 and to 1. Now this is the expanding of in factorials. Generally we use this formula, but we can also write in this ascending or descending form. Both form we can write. Its notation is in factorial, and another notation we can also use for the, we can write this one, that is used in gamma, that is also gamma, and in factorial is used in here also. So now this we can also write this terms in different ways. So we can write n into n minus 1, n minus 2, n minus 3, n minus 4 up to so on. For example, we reduces up to 3 terms in here, so we can write n minus 3 factorials. Similarly, now this term, if we reduce, n factorial is equal to, for example, n into n minus 1, n minus 2 factorial. So these two results are same. That is your choice. Whenever you are needed to the term up to term, you are expand these terms. Further, if we reduces in the form of, for example, we can write as equal to n into n minus 1 factorial. Just if we have n minus 1 term is required, so both term are same. It should be noted, keep in mind, note, and never be negative, this term always positive, because we have already discussed in the definition of factorials, n must be in positive integer, never negative accepted in here. So for example, we can write this term 0 factorial. How we can prove that is equal to 1? Very interesting. This topic is very interesting in here. 0 factorial is 1. How we can prove this one? So according from this definition, if we are applying in here, for example, if we put in here n plus 1 factorial. N plus 1 factorial is equal to, in the place of n plus 1, n to n factorial. According to this definition, we can write. Now if we put in here in this definition, put for example, we are needed in here 0 factorial. So we put first we explain this one. We are needed n factorial is required in here. So this term is divided on in here is equal to n plus 1 factorial divided by n plus 1. Means this term is divided on both sides, so we get n. Now we put n is equal to 0 because we are required 0 factorial. So this term we replace in here 0 factorial is equal to 0 plus 1 factorial divided by 0 plus 1. 0 plus 1 we get in here 1 factorial, and in here 0 plus 1 we get in here 1. So 1 factorial is equal to 1 and divided by 1, so we get in here 1. It means that, so 0 factorial, we have verified this one, 0 factorial is equal to 1. Now generally, now we are proceed, for example, 7 factorial we are expanding, so consider here n is equal to 7, that is consider n is equal to 7. According to this formula we have already done, n factorial is equal to, we are expanding n into n minus 1, n minus 2, n minus 3 up to so on, up to 3 to 1. If we put in here in the place of 7 factorial, so will be equal to 7 into 6 into 5 into 4 into 3 into 2 into 1. So if we shortcut, we can write this term 6 factorial we can write. These two terms are same with this one because 6 factorial we can write. Now 7 factorial is, this 7 is divided in here, so we get 7 factorial is divided by 6 factorial. So now 7 factorial we can write 7 into 6 factorial is equal to 7 is equal to 6 factorial. So both are cancelled. It means that 6 factorial is equal to 6 factorial. So the similar process we have done already in the factorial, 0 factorial, how we can prove this one. Now for example, if we are expanding 5 factorial, so 5 factorial we can write 5, 4, 3, 2 and 1. So if we are multiply this term, so this will be equal to 120. Similarly, if 4 factorial we are expanding 4, 3, 2 and 1, so this will be equal to 24. And 3 factorial if we are expanding 3, 2 and 1, according to this definition we get if factorial different elements, how we can expand by this one. For example, if we are expanding n plus 1 factorial, n plus 1 factorial, according to their definition, you consider in mind this one, put here is given that is n. So we keep in mind n, that is n plus 1 is n, and n minus 1, and n plus 1, n minus 1. So look here, this is cancel. It means that n plus 1 into here is n factorial is remaining. So the general formula we get, we have already done this case, the factorial case. N plus 1 factorial is equal to n plus 1 n factorial. That remember, this formula is very important. And here example number first, 8 factorial and 7 factorial. Look here, the greatest term we want to check in here is the value is in here, numerator and denominator. Here 8 is greater than from 7. We can write this term 8 into 7 factorial. Up to 7 factorial is already present. This will be cancelled. We get in here 8 is the answer. That is already we have done the example. And part, this is part A, and part B is given that 5 factorial and 2 factorial, 3 factorial, how we can calculate this term. Now look here, in the denominator is maximum number is available is 3, so it means that this term we are expanding up to 3 term, 5, 4 and 3 factorial, and 2 factorial, 2 into 1, and this factorial will write in here. This will be cancelled, and 2 and 4 is also cancelled. We get in here 10 is the answer. Similarly, divided by 1 divided by 2 factorial and 4 factorial, that is factorial, plus 1 divided by 3 factorial and 3 factorial. Now look here, 3 factorial is double is repeated, and here is 4 factorial. It means that we are required 3 factorial from this term, so we can write this term 4 2 factorial and 4 factorial. We are expanding according to the definition 4 into 3 factorial. So plus 1 by 3 factorial and to 3 factorial. Now 3 factorial we are taking from the denominator term is common, 1 by 3 factorial is common. So here is 1 by 2 factorial and 4 is remaining, and here is 1 by 3 factorial is remaining. Similarly, now here is 3 factorial. It means that here is 2 factorial. It means that here is 2 factorial is already present. Expanding this term again, so 3 factorial, and we can write 1 by 2 factorial into 4 plus this we can write 3 into 2 factorial. Again we are taking 2 factorial we are taking common, so this will be equal to 3 factorial and 2 factorial is common, so 1 by 4 and plus 1 by 3 is remaining. Now we are expanding this term. Here we get we are taking LCM. This will be, we get in 6, 3 factorial is equal to 6 and 2 a factorial is 2, and here we taking LCM. 12 is LCM. So 4 multiplied by 3, 12 we get 3 and here, and 3 multiplied by 4 we multiply by 1 denominator 4. So we are simplify this term 1 by 12, so this will be 1 by 12 and 7 divided by 12. Again we get in here 7, 1 by 12 multiplied by 12, when we get 144. So that is the answer of this question. We can also use another method by easily method. We are expand each term, so we can also apply this method. Exercise 6.1. Question number 1. Evaluate the following terms: 10 factorial, 3 factorial, 3 factorial, and 4 factorial. Now look here, 4 factorial is in here, and here is 10 factorial. Means there's this term 10 factorial is expanding, reduces in the form of in here 4 factorial. So we can write 10, 9, 8, 7, 6, 5, and 2, 4 factorial. And 3 factorial we can write 3, 2, and 1, and similarly this 3 we can write, and 4 factorial. This 4 factorial is cancelled. This will be 6. This 6 is cancelled. 3 multiplied by 3 we get 9. 2 multiplied by 4 we get. Now if we are multiply this with 30, 120 up to so on, so we 4,200 we get the answer in here of this question. 4 factorial, 3 factorial plus 4 factorial divided by plus 4 factorial. So this is the second part of question number 1. So we can also use common methods or simplification. Mini method you can use in here. Now look here, 3 factorial plus, and here we can reduce it in the form of 3 factorial. 4 factorial we can write 4 factorial. 4 factorial we can write 4, 3 factorial. Similarly, and 5 factorial we can write 5 and 4 factorial plus, and 4 factorial is already present in here. So 3 factorial we are taking common. 3 factorial is common, and here is 1 is remaining plus, and here is 4 is remaining, divided by, and 4 factorial if we taking common in here. So what is the remaining? And 5 plus 1 is remaining. 3 factorial, further 3 factorial, this will 8, where 8 we get here 5. Similarly, and 5 factorial we can write 4 factorial, 4 into 3 factorial, and here is 6. Now 3 factorial and cancel, we get in here 5 divided by 24 is the solution of this question. Third part, n minus 1 factorial into n plus 1 factorial. Now look here, n plus 1 is greater than from n minus 1. It means that we are expanding this term n plus 1 factorial. If we are first n plus 1 factorial according to the formula, we are expanding this term. So we can write n plus 1 into n plus 1 minus 1 n plus 1 minus 2 factorial. Now this term we will get in here, look here, n plus 1 into n, this will be cancelled, and here is n, and this will be subtracted, n minus 1 factorial. Now look here, n plus 1 factorial we can write in this form. So we can get in here n minus 1 factorial, n minus 1 factorial divided by n plus 1 into n into n minus 1 factorial. So this will be cancelled to each other. We get in here 1 divided by n into n plus 1. Now this is also we can expand n into n square plus n we can write. This is the solution.